summation portion of the training film, we're now going to utilize all of the information that we've learned to literally solve problems, and I think, if you'll bear with us, solve problems that you may have not been able to solve before. And this is because you have an idea of what radio patterns are about. And if you really don't, you probably ought to skip this portion of the film and go back and review the first part of the training film from conductive through inductive couplers, because understanding radio waves and how they relate to your locate will be very important to this portion of the film. Give you an example. Everyone that's ever located near a transformer or a telephone pedestal knows that this is the transformer enclosure right here. This cable's easy to locate, that cable's easy to locate, but this is what's known as a disaster area. Give you an example of why. Back in the first portion of the tape, we made a statement that when cables are together, and if the field pattern is going the same direction, that would distort. Maybe we go back and remember that we had the field pattern coming up, locking horns with this guy right here, and we ended up with an elliptical field pattern that would go that way. And then we showed that, you know, two cables being that way could give you an ellipse in almost any angle. We have another situation that we need to talk about, and that's, you know, this one, we're going to get distortion when the two fields are going the same direction. What happens when the two fields go opposite? For instance, right like there. There's two cables. We've got a radio field going, but we've got a radio field going this way. Those two radio fields go opposite. If we would actually take a receiving antenna and put it right there, in the peak or the null mode, wouldn't make any difference. But we put a radio field through in that angle. And then we took an opposite but equal field going through in that angle, we would not see any signal whatsoever, because those two signals would neutralize. They'd still be there. They're not canceled, but they neutralize themselves inside the antenna, so the electronics has nothing to pick up. Let's see where the problem is right here. If two fields going opposite directions will neutralize inside your receiving antenna, let's put our transmitter down at this end. Notice if we stop action, and this will be the key to your locating. If you can physically visualize these radio waves, that they, in fact, increase and decrease, and even more importantly, they've got a direction to them. The direction and how that relates to your antenna is everything. So let's just stop action this film in the clockwise mode. See how that tone is going clockwise? Look here, as it turns the corner, it's going clockwise. And it goes into that neutral tie point right there, or where the cables are tied together. It comes back out clockwise and then continues on down the line clockwise. Now, since it's clockwise and clockwise here, and it's by itself, we can locate that. But notice these two radio patterns are actually going opposite of each other, just like right here. What did we say about that? When field patterns go together in phase, we get distortion. When field patterns are opposite, we get nothing. That's why we have a disaster area right there. Now, if we had put our transmitter here instead of here, because we could put it down here and it wouldn't make any difference, would it? If we put our transmitter at the transformer enclosure, notice that this is now clockwise, that's clockwise, this one becomes clockwise, this one becomes clockwise, this one is clockwise. Now, these two are opposite of each other, but who cares? We're out here locating by ourselves. In here, we would get distortion, but at least we would make a locate if we put our transmitter right here. If we put our transmitter here or here, we cannot locate that area with anybody's locator. Let's erase this now and go on to the next picture. Here I've placed the transmitter with on the direct output. Instead of hooking onto a cable and then putting a ground plate out, I've just taken that wire out and looped it around, and this could be 100 feet long, 50 feet, any length. and I've connected it to both sides of my direct output of my cable locating transmitter. I would not be able to locate that wire even laying on top of the ground at 0 depth. Why? Because it's an AC wave and it's going to keep reverting back and forth, but as the tone goes out, it's going to come back on itself. And what did we say about this situation? When we have two cables that the tone is going opposite each other, we get the cancellation. And so I put this picture up here to show you that if you can make the radio wave or understand what the radio wave's doing and then actually make that radio wave do what you need to have it do in order to pull a locate out. Another example. I'm sure we all know what a slinky is. A slinky is a spring that you sit on the stairway and have fun with your kids, and the slinky goes down the stairway. This here is our slinky. Please note that the spring is expanding on the outside and it's contracting on the inside, isn't it, as it makes its bend. Well, if we would actually call that radio signal from our transmitter, and we're going to put our cable inside there and say that's our cable, that's going to be the radio tone that our transmitter put on the line. So we've got this radio tone that's coming down. Notice how that radio tone is expanding on the outside and it's kind of contracting on the inside. Well, whether it be from two separate cables or from itself, anytime you have field coming, we said when the radio field was going in the same direction, it would cause distortion. This is where we got the elliptical, way back early in the field. We have right here, the radio field on this cable is starting to come back on itself. This was where it was normally that far apart. All of a sudden it's getting tight in here. The bunching of signal not only will bend the radio field and make it come up crooked, it's actually going to go elliptical on you to where it becomes the crest of the wave is out here. And many times you will actually lose your null in the middle of a turn. Let's just say the cable is going along turning. All you know is you're walking along in the null mode, you've lost your null, and then when you pick up the null, you're going a different direction. And this is why. You'll also find that your locate is going to be on here, but your locate is going to drift to the outside of that turn often. And the tighter the radius, the worse the problem becomes. Because as this radio field becomes an elliptical radio field, out here is where the crest of it is, whereas if it was a round radio wave, that would be the crest. So as this radio wave actually becomes elliptical, your locate will not be on the cable. In fact, it will move to the outside a little bit. Now, how many times have we plowed a trench? We've gone out where actually they plowed two cables in the ground. You can see the plow mark in the ground. You can still see where they put the trench. And that's right here, and that's right here. And you connect up with your locator, and you are physically locating to the outside in both cases. And you know darn well your locator's lying to you because you can see where they plowed the cable, and they didn't plow it on an angle. They plowed it straight down, okay. What's happening is that this repulsion of signal is taking place again, and the field pattern is actually going elliptical on you, and the crest of the wave is moving over here, and it's moving over here. So when you have two cables in the ground, this field pattern is trying to flatten out and go elliptical on you and will actually show off to the outside edge, which means when you place a transformer, as we showed on the other picture, and we said you could locate that area, if you put the transmitter here, you're going to locate just a little bit to the outside of where the physical cables are, right there. And then as you pull it around, you'll be able to pick that one up and pick this one up. These field patterns do take on peculiar shapes when they are approaching each other. And now I'm going to erase this upper part of the film because I want to show you something with primary cable. Now, when we have a primary cable right here, we've got a concentric neutral which is spiral wrapped. And it's coming up on the back side and it's going around and it's coming up. So this is right here. The problem that we're going to get into and primary cable is harder to locate than secondary cable because the secondary cable is a rubber jacket. It's continuous. Primary, this radio field pattern is going clockwise, and as it comes back up around, this radio field pattern keeps coming back on itself. Can you see where these radio field patterns going together is the same as we had right there, which is causing distortion. So primary power cable in the ground, some of this energy is being canceled, some of it's being distorted, which means the tracing range on a primary cable is not as great as it is with the secondary. The other thing I wanted to touch right here is let's make this now a transformer, and let's make this a triplex going to a meter. We've got these three cables coming in. We made the statement that the 60-cycle cable locator way back in the very beginning would not work well on secondary cables. Worked well on primary, worked well on street lights, didn't work so well. And that's because if you have 10 amps here and 10 amps here going into the house, your neutral current is coming back in that direction. And what did we say? When we have cables that have opposite, we get cancellation. So the return current coming back on neutral cancels the current that you've got going to the house, which literally means 60 cycle. On a purely balanced load, 60 cycle locators would not work. It's the ratio, the phase, and the amplitude. Going to the house and asking the lady to turn on the oven won't necessarily both legs come up the same amount. Turning on one hot plate probably would do a better job. Okay, let's now go to the next picture and show you how to make a locate in a no-locate area. On this picture, we're showing a transformer. This is the handhold, and maybe this is two trailer houses. Notice that the cable is split here for this trailer to that trailer from this handhold. How many times have you gone out with your locator, and whether you be in the null or the peak mode, it really doesn't make a whole lot of difference. You're walking along and you're getting a good crisp locate, and all of a sudden there is no tone, just like your receiver has died. You continue to walk or look around, and pretty soon over there you find tone, and now the locator is working great. Come back to this area and you can't locate. And this is really the area that we're talking about right there. Because I can locate that cable easy, and I can locate that cable easy, and that cable easy, and this cable right there is pretty easy to locate. But this can be a problem, and I'll show you why. I've, on this drawing, split the two cables apart, recognizing that they are buried together in the same trench. I separated them here for the drawing purposes so you could take a look at the field pattern. The first thing we do, because we know it takes two people to locate or to open a transformer enclosure in most utilities, the easy thing would be to go to that trailer house right there and clip the inductive coupler onto the meter riser, because that always works. Well, let's see what happens in that area to find out why this is a no-locate area. See the tone starting to go clockwise? Here it's coming this way, it's going clockwise. The signal that we've got is actually coming this way. It's going clockwise, the radio field pattern is. It's going clockwise. But you see here, remember we said when signal patterns are going opposite direction, we get the cancellation, don't we? So that's why this area becomes a no-locate area. Anytime a cable folds back on itself, you're going to have a problem if you're driving it from that end. What you want to do is put your transmitter in the area where the signal's all going the same direction. In this case, instead of here, I could go over here and it wouldn't change anything. In this picture, we put the transmitter at the transformer, and look at here. The signal is going clockwise, 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 clockwise. Now, we'll get distortion in that area because it's two signals going together right here, but at least we're going to be able to make the locate. So, does it make a difference of where you put your transmitter? You bet it makes a difference. Let's go on to the last page now, or the last picture of our training film right here. and show you how I would approach a subdivision. This is a picture of a subdivision, and I want to prove a point. In the film thus far, we've talked about nulls and peaks and direct outputs and how important impedance matching is and how important inductive tracing and inductive couplers, but probably the most important thing that we want to get across in this film is that this radio pattern will take on funny shapes and do some pretty weird things once it's in the ground, because the transmitter can only put out a radio tone. And I don't care whether it's low or high frequency or whose brand it is. A receiver can only pick up that tone. And all the bells and whistles that you can put on your receiver or transmitter is not going to make you locate that cable any better. It's the knowledge of your equipment, it's the fundamental knowledge of what radio patterns are doing. Let me prove a point here, because you and I are both going to go out. These two are identical subdivisions. I'm on one side of the street and you're on the other, and they are absolutely identical. And in both cases, a road is going to come up here, and there's kind of a parking area right there, and there's a couple of big dogs in the area. So I'm going to put my car right here, and gee, in the other subdivision, you put your car in the same spot. And we both arrived at 9 o'clock in the morning to do this subdivision locate. At 10:30, I'm back in the office, and I'm all finished. And gee, noon comes by, and you radio in that you're going to go get a hamburger because you got problems. At 2 in the afternoon, you radio in and said, well, I may be late. Along about 3:30, you finally arrive at the shop, and you've got your area located pretty good, but you've also got an awful lot of the area which is what we call non-locatable. Well, how come I was able to locate all of the cables and you were only able to locate some of it? And then it took you so long. I not only located all of mine, but I did it in an hour and a half. Let's go out and take a look. This is transformers and handholds, and please recognize that right here we've actually got the cable going this way. We've separated it on the drawing here just to show you what's going to happen with radio waves. But in fact, they're in the same trench. So how many places can we put our transmitter? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and we've got 14. So the first thing you count up and say, well, I've got 14 different places I could put my transmitter to my cable locator to put tone on the line to use the receiver. And my answer back to you is, are you sure? I don't think we have 14 places we can put our transmitter. Because look, that's what you did. You parked your car and jumped out and immediately went to that meter riser right there and placed tone on the line. And immediately you got into a no-locate area. Why? Because look, the tone folds over on itself. Remember when I said if the tone's going clockwise and it turns and it comes back clockwise, we have a no-locate area, don't we? That was just like that cable we put on the transmitter like that. And that's in fact, so this area, if I put my transmitter, the tone's going to start out clockwise. Gee, it's going to come back there. That won't work. And if I put my transmitter here, that's not going to work either. If I put it right here, I'm going to get a clockwise, and as it turns around, it's going to go clockwise. That's opposite. This is the no-locate area. By putting it right here, I could trace this cable, but I've got all this no-locate area. So what I'm going to do is take a look at my plot map and say, gee whiz, that's not where I want to put my transmitter. That's not, that's not, that's not, that's not. This I could put my transmitter here, because if I put my transmitter right there, now the tone's all going to be going together. I'm going to recognize I've got distortion in this area, but at least I've got tone. I'm still not going to put my transmitter right there because I've got a fold over right here, don't I? So I'm going to say, okay, this position or that position, I can put my transmitter, and I'm going to bring all the signal this direction. So let's just run back to this house right here. This may be the better spot because of length. If this is the long tracing distance, I can trace this direction and this direction from this point. but it may be hard to get at. So in either case, let's put the transmitter on right here. We're going to put a clockwise tone. That's clockwise. That's clockwise. Gee whiz, all these are clockwise. So everything is locatable from one position. We don't have 14 places to put our transmitter. We've only got 2, or maybe 3 or 4. In other words, this point, that point, and that point is the only 4 places we could put our transmitter. Now, if I put my transmitter there, I can literally, if I've got range from my transmitter, I can literally make every locate in that area from that one connection. Because in all cases, the tone is going together. It would have a fold over. As it went clockwise here, it would turn and go clockwise there. I would have a reversal of phase right there, or a no tone area, which came back as we talked about earlier. And I could locate, of course, I could locate that area from this one push. So from 2 connections, I'm able to make the entire locate and to make all of the locates where you were fumbling simply because you didn't understand this radio feedback fold over, which would neutralize in your receiving antenna. If you can stop and try to analyze what this radio field pattern is doing and how it relates to your receiving antenna, it's going to make your job a whole lot easier. And don't be afraid to experiment a little bit. Locating can be fun. And at this point, you should, in the training film, you should know pretty much how to use your locator in the conductive mode. You should know the inductive mode of tracing. You should know inductive couplers. You should know the radio field pattern, how it can distort and why it can distort, and what you can use your receiver to do to solve some of these problems in analyzing. Don't be afraid to go to your pickup, get a piece of paper. If you don't have a plot map, draw the system. See why you have a problem. Lay in your radio waves. Once you can start seeing that radio wave is not only expanding and collapsing out there, but it's actually got a rotational direction to it. At the same time, if it's going clockwise here, this is going clockwise, but that over there is going counterclockwise. Now you may be able to understand why some of these locating problems exist. One thing we know for sure, the transmitter only knows how to put out the signal, the receiver only knows how to pick up the signal from below ground. Sometimes this signal is going to not come straight up above ground. This is what we've tried to cover in this training film. What we'd like now to tell you also that Aqua-Tronics is going to do everything it can within its power to be of service to you in any way, shape, or form that you need help. We have local reps in your area. If you have a problem with a locate, one that you don't understand, contact our local representative because he is a factory-trained man that understands radio waves. He can come in and maybe work with you and solve these problems. The one commitment that we've had and had for over 20 years in this industry of manufacturing is a total commitment to the underground problem solving. You as a customer, you're what makes our company exist. We're not going to forget that. Thank you.